let's share some thoughts about the future perspectives of these AI tools, high content imaging and so forth. What, in your opinion, would be the next major developments in high content imaging, artificial intelligence, that would further enhance the efficiency and the accuracy of such approaches in early research?
I think, we were talking about the challenges of obtaining these data sets. This is one thing which is quite challenging. And I believe their advances in this field would help that, because you could then more easily get multiplex data. You could feed the beast more easily. That's one thing. I'm sure there's a lot of things that can be done on the networks themselves. It's talking to mathematicians. They find them that they are not sparse enough, and that the random initializations of weight should be actually simulated to not have a random initialization, and so, things like that. There are very interesting advances also in physical objects being used for machine learning, where you have chaotic acoustic cages or chaotic light cages, which can learn patterns and then predict new patterns. So it's wild. It's wild what's going on at the moment, so there's going to be a lot of advances also into types of networks we're using, and the large language model is one of the latest big development, and its roles in different applications is still being investigated actively. There was one that just came out, I believe, last week, where a large language model was used to predict and ameliorate antibodies, therapeutic antibodies talking to that was SARS-CoV-2 protein, and predicting better how to have neutralizing antibodies in the light of problematic variants of concern. I believe there is just going to be a lot of advances there. One thing which is, how good are they at predicting the mode of action? How good are they at really understanding what is going on? I believe that is going to be interesting, because I see still a big problem that we have in our high content imaging data sets, is that we're missing two classes of very, very important components in the cells. That's on the one side, the metabolome, and on the other side, the lipidome. These are very important compartments to which we're completely blind in most of the cases in our screening assays, in which we know from the biology have a gigantic impact. And we ignore them because we basically don't have the reagents to detect them. And that's something which I believe we'll see how important, whether you can infer the lipidome and metabolome from the rest of the data you have, the transcriptome and the proteome. But we're missing half of the most important molecules classes. Yeah. Now, I think this is one of the problems we are having in having more accurate predictions in preclinical data.
CELLIMA, science that works for you.